paths along the computational graph will happen in parallel. It's not that one is going to happen and then the other, as we've seen in our serial chains. We have these happening in parallel, right, at the same time. After which we get the result, which is the output of a parallel chain that will contain the title property and the word count property. Okay, so parallel chains are runnables, right? And therefore can be composed with other runnables. And we should keep in mind that the output of a parallel chain is a dictionary, as we saw above. Some runnables, like prompt templates, for example, expect dictionary values as their input, but others may not. Now, of course, as we discussed when we introduced runnable lambdas as kind of a common use case, we can construct custom runnables to handle the output of parallel runnables to reformat them if needed. So with our current toy exercise, for example, should we wish to create a simple printout of both our title case title and its word count, right? We're going to use both of these pieces of information in the final result. Then we can create a runnable that expects a dictionary as its input and then uses its values to construct the output. So here we're going to create a runnable lambda called describe title. It's going to expect a single value, and this single value is going to be a dictionary. It's going to return a string that is going to use the title property of the input dictionary, the word count property of the input dictionary, and it's going to say that the title has however many words. Excuse me. So just to test out describe title, let's invoke it with a title, which will be just the title of the course and the word count. And you can see that we get a string back that says building large language models with prompt engineering has 7 words, just as we would expect. So now that we've sanity checked that it works, let's create a new chain. We'll call it final chain. And the way it's going to work is we're going to use our parallel chain, which, as you remember, will return a dictionary, and then we'll pipe that dictionary into describe title, which expects a dictionary as input. And with that final chain, we can again look at how it is represented in this computational graph where we have our parallel output, after which the combined output of those parallel operations is passed into our second lambda function, and we get our final output. And therefore, if we invoke final chain with the lowercase title, it performs the 2 operations in parallel and then performs a final serial operation where it creates this output string that uses all of the information that was calculated earlier in the chain in parallel. Okay, so if a lot of that was, if that feels muddled to you at this point in time, I might recommend you pause the video and kind of go back through that section 1 or 2 more times, just to make sure you kind of understand what's going on. It's not too complicated, but if it feels fuzzy at this point in time, we're really just going to be building on it as we go through the rest of this notebook, so it's worth getting that part solid before you continue. Okay, so as a matter of convenience, LCEL allows us to replace calls to runnable parallel with simply the dictionary literal that we would have passed into runnable parallel. This is purely a matter of syntactic sugar. And personally, I prefer the more explicit use of runnable parallel. But you are going to see this syntax out in the wild. So I wanted to make sure that you were aware of it, as well as some gotchas, so that when you do see it, you're not too confused about what's going on. So here's an example of this syntactic sugar. So here's the definition of our final chain, but it's fully articulated using runnable parallel, right? Where we're going to invoke runnable parallel, we're passing in our dictionary where we perform our title casing and our word count in parallel, after which we pipe the results of that into describe title. And we're just going to call that final chain as we did above. Now, if we wish, right, we can use this kind of syntactic trick that LangChain gives us to rewrite the chain as follows, where we remove the call to runnable parallel and simply leave only the dictionary literal. So this final chain here, right, where we only have the dictionary literal and then pipe it into describe title as above, is in fact equivalent to this more long form version of the final chain. And just to prove it, now that we've overwritten final chain with this more concise version, we can invoke it, and you can see we get the same result as we would have expected. Now, there's some gotchas to this syntax, right? Let's consider if we had a parallel chain, right, that didn't involve describe title. All it did was this first kind of parallel step where we are generating the title and the word count in parallel. One way we could define that is by using runnable parallel explicitly, and that's no problem. We could then invoke this and it would work as expected. However, now if we try to use that syntactic shortcut and replace the call to runnable parallel with just the dictionary literal, then we end up with a line of Python code like this one, right? Parallel chain equals the following. Now, if we've kind of got our head deep in LangChain land, it may not even occur to us what we just did. It didn't throw any errors, whatever. But look, if we actually try to invoke this, you can see we get an error. And it makes sense. It's saying a dict object has no attribute invoke. Because again, if you just kind of like step back for a minute and look at this line of Python code, all we've done is define a dictionary literal, right? That's exactly what we've done. So the point being that you have to be a little bit careful with the syntax, because if you don't use it in the context of a larger chain, like you're doing here, then where LangChain kind of under the hood is taking care of parsing all this out and doing what's necessary with it, then you end up just defining a dictionary literal in Python. And of course, you haven't done anything in your code to express that it's actually a LangChain chain or a LangChain parallel chain. So you just end up with a dictionary literal. So just kind of keep that in mind. And personally, I recommend just explicitly using runnable parallel. It's, not that much work to type it out, and I think it makes your code a lot more clear. Okay, so this is a bit of a mini project, and it's going to be broken into two parts. The first part is where you're going to think about your approach to the mini project, and then the second is going to be where you implement it. So let me explain the exercise to you first. We're going to revisit the exercise that you completed at the end of section 1 when we had first introduced you to prompt templates, but before you learned anything about LCEL chains. And if you recall, in that exercise, you were given the following list of statements, which we're going to define again here for use in this notebook. And your goal was to create prompts for sentiment analysis, main topic extraction, and follow-up question generation. And ultimately, you created a summary output that looked something like the following, right? Where for each of these 5 statements, you had the overall sentiment, you had the main topic identified, and you had a follow-up question. Okay, so we're going to be doing that again. However, you're going to do it using chains, and in particular, you're going to use parallel chains where possible. But to get you started, right, because we don't want you to spend a ton of time redoing work that you've already done or having to go like copy and paste stuff that you already did, we're going to provide you with several of the runnables that you're going to be able to use in your solution. So first, we just went ahead and created 3 prompt templates for you. Here's a template that works just fine for sentiment analysis, one that works just fine for main topic template, or for main topic identification, and one that works for follow-up question generation. And you can see each of these expects a single parameter, namely text. So you can and probably should use these in your solution. Next, we'll create the output parser instance that you're going to be using, so that's already there. And then finally, in order to generate, this kind of summary output, we're going to create a runnable lambda here that just prints out the output. You can see it assumes a dictionary as its final output, or as its input rather, and then uses that generator or uses that dictionary to construct the output kind of in a pretty printed format. Okay, so you've got all of these runnables now. You've got templates, you've got an output parser, you've got a string output parser, you have an LLM instance, okay? The next thing for you to do, right, is to spend some time thinking about how you ought to compose your chain, your large chain, including any subchains you want to create. And in particular, we really want to challenge you to think about if there's any situations in this task where you might be able to do parallel execution. Okay, so I'm going to ask you to pause the video here for several minutes. If you actually want to do some writing or typing, here's a little markdown cell where you can type your plan, right? I mean, whatever works for you, right? You don't have to write it out, but I think it's a good idea to write it out. But spend some time seeing if you can construct or think about where you're going to be able to do parallel execution, and given the various subcomponents of this larger mini project, how you're going to construct your final chain, including its subchains and its parallel chains, parallel subchains. Okay, so pause the video here, work on that for a little bit. Don't actually try to implement the actual solution yet, right? Just work on a plan, and then come back, unpause the video, and we'll show you kind of how we thought through the planning step of this process before kicking you off to actually implement the mini project itself. Okay, good luck with your plan. Okay, I hope you took some time to actually think through this. You know this as an engineer, there's so many situations where a little bit of thought up front really makes the execution much, much easier. So hopefully you took some time to think through this and have a good idea. Okay, so here's kind of a long cell. It's a little bit like chain of thought, but this is how we thought through constructing this final chain. You may not have done it exactly this way. Maybe you came up with it a lot quicker or through a different method, that's fine. But just as an example of how I think about like constructing a larger chain and identifying where there's parallel construction, here's kind of one example. So I know that the inputs for this entire process is going to be statements, and that the ultimate output is going to be formatted output. That's kind of a given at the beginning. So if I work backwards from formatted output, which I know is expecting a dictionary, right? There's 4 values that I need to provide formatted output. I need to provide it the statement itself, the sentiment of the statement, the main topic of the statement, and the follow-up question for the statement. So it seems to me like I might be able to capture statement somehow. I'm kind of going to punt on that till a little bit later. However, for sentiment, main topic, and follow-up question, I know that each of these are going to need to be their own LLM chain, right? These are 3 kind of independent LLM related language tasks. So now I still have my statements, which are ultimately going to result in the formatted output. But here in the middle, I need to extract a single statement, and then I need to create a chain for sentiment analysis, which will involve my prompt template defined above, my LLM instance, and my parser. I need another chain for main topic generation, and I need a third chain for follow-up question template. Now, just as an observation, again, I'm kind of pretending like I'm thinking through this the first time. It seems to me, at least, that sort of everything in my outline between these brackets that I've created are independent of each other. I don't actually need the sentiment analysis to do the main topic generation, to do the follow-up question generation, etc. So I'm kind of thinking to myself that it's likely that everything I have captured here, likely I'm going to be able to do these steps in parallel. Okay, so in order to move from my 4 parallel chains, which is going to return a dictionary,